Hello everyone, welcome back. Let's continue with the second part of the video. Those who haven't watched the first part, I would highly recommend doing so in order to fully understand the topic. The link of the first part you can find in the description below. Then let's define report definition. You can see the detail of report definition in my previous video. I will provide the link in the description. So we want to check the temperature of the ICs during the simulation. So let's define for that volume average temperature. For that, let's call temperature IC1, volume average temperature static IC1. Uncheck these two and create output parameter. Okay. Similarly, let's copy this one and define IC2, IC2. Uncheck these two. Check create output parameter. Okay. And other one for IC3, IC3, check this one, create output parameter IC3 and click OK. The last one, the outlet temperature, for that's mass weighted average temperature, outlet temperature we want to define here outlet. Uncheck these two and create output parameters. Here you can see I have defined 4 input parameters, which are the heat generation in each ICs. So in cell zone, so when you go, so when I was defining, so I have created input parameters. So I have defined those 3 for this one and 1 for the flow rate. Similarly, I have defined 4 output parameters. So it means we will get these results as an output. And we also want to plot this one. So let's create new temperature plot. So I want to plot these 3. Click OK and close. I'm not changing any simulation setting because that is not the purpose of this video. So then just initialize your simulation. I'm initializing with hybrid initialization. So there are different ways of initialization. So you can check. I will show you the initialization panel in a second. Here is your initialization panel. So you can choose different ways of initialization. Anyway, then run calculation, define number of iterations. So I'm defining 1000. Actually, first you need to define number of iteration, then initialize. After initialization, close the Fluent. Yes, okay. Then go to the workbench. Here you can see this parameter set tab has been appeared. Double click on this parameter set tab and here you will get this display. You can see in table of design point you have all those your input and output parameters. So heat source 1, heat source 2, heat source 3 and mass flow. These are all those parameters which we have defined as input. And here you can also change the units. These are only display units. So for example, for mass flow rate, I want to define in terms of gram per second. Here you can define your different design point. So I want to run for same heat flow but with different flow rate. So 4 and 5. Also, as I told you before, I'm putting 0, but we can change this one later. So let's put same heat source as here. So you can simply copy paste as you do in Word or in Excel. Now, all these are your output parameters which we have defined: temperature IC1, temperature IC2, IC3, and outlet temperature. All these signs are showing that these are not updated. If you click over here, update all design point, it will update all these your design point or all these simulation. or if you right click and you can say update selected design point. In this case, it will update only or it will solve only this one. So let's click on this one, update all design point. Meanwhile, you can do one more thing. So come back to the project. Here you have this parameter set. So here your input parameters and here your output parameters. So go back to the project, right click on the solution and click on the solution monitoring. In solution monitoring, you get this display. So here you can monitor your solution. For example, here on the bottom, you have this console. It is the same console as in Fluent. So you can see the progress of your solution. On right side, you can display different graphs. For example, here is your residual. So right now the residual is being plotted over here. You can also display, for example, volume report. We had defined these plots. So if you check this one, so we had defined temperature IC1, IC2, and IC3. So temperature of these three ICs you can also monitor over here. So you can switch the display between these two. Here, some of the setting for your graph. So you can change, for example, what kind of scale you need. You want to have linear, logarithmic, or whatever scale you need. So you can define over here, or you can change. Right now, I'm going to stop this simulation because I have already completed this simulation and I will show you a few things over there in the solution. Another important setting in the solution, go to the properties and here you will get this property tab, and here you need to select initialization method. Here it says program control, change it to solver control. It doesn't matter in steady state simulation, but in transit simulation, if you leave it to program control, so it will initialize your next simulation from the result of the previous simulation. So it means your initial condition will be different. So that's why choose it to solver controlled. So it will always initialize your solution with the solver setting. Here I have opened the results. Now double click on the parameter set. So it will open all those results. So it is showing that all these simulation have been finished because we have these results. Before here you could see those lightning sign. Now these are numbers indicating that simulation have been finished. I did not retain all those data because I had some limits. I have limited space. What does it do? So if you don't click over here, it means the data will not be retained. So you will get only result over here. So there is no data available on my machine. So if you want to retain data, so you have to click over here. And now you can see you need to update this one. So for that, now if I want to open any of the simulation, for that I have to go, for example, I want to open design point 1. So right click and set as current. So it will set it as a current. It means now if I will open this setup or simulation, it will open this result. So why it is showing that this one is not solved, because I did not retain data and now I'm retaining, and it means to retain data I have to solve once again. So I'm not solving again, but before running simulation, if you would have retained data, you didn't need to solve once again. And for example, if I right click over here, I cannot see set as current because there is no data in the file. Only these are the results which are available for the third design point. It means I have results only for the design point 0. So let's see the results for the design point 0. Right click, set as current, go to the project and open solution. Meanwhile, you can see when we have the flow rate 3 gram per second, so the temperature was for IC1 329, and for 4 gram per second temperature was 327, and for 5 gram 325. So as the flow rate is increasing, we get lower temperature for ICs. Anyway, let's check the results into the Fluent. I have opened the design point 0. So let's check the temperature distribution. For that, go to the graphics, contour. I have already defined this contour, so go to this temperature and select all these and temperature static and save display. Here is the temperature distribution on the PCB. The temperature of this IC is quite high. And the reason is that the cooling channel is just passing near to this IC. It is not passing exactly underneath this IC. Anyway, we're not going into the detail of those results. Just want to show you how it looks like. Anyway, you can open any of the simulation by right click and set it current, and that's how you get your parametric analysis. In this way, you can run as many simulation as you like by a single click. So that's it for today, and see you in the next video with the grid resolution study.